Welcome to the lesson on triangle similarity. In this lesson, we will discuss the conditions necessary for triangles to be similar and how we can use similarity to solve problems. By definition, similarity means that two figures are the same shape but different sizes. Then those figures, all corresponding angles are congruent and all corresponding sides are proportional, which means they'll divide to make the same amount. So let's imagine two triangles are similar. Triangle ABC is similar to triangle XYZ. So the corresponding angles, that means that A is the same as X, B is the same as Y, and C is the same as Z. That those three pairs, each pair are congruent. They have the same angle measure. The sides are also proportional, which means AB over XY will be equal to BC over YZ and AC over XZ. So I can take a look at these two triangles with actual measurements and see that 10 over 5 is equal to 8 over 4 is equal to 6 over 3 because all of those are 2. Now we can use these principles of similarity to find missing sides. So let's say I have two similar triangles and I'm going to make the assumption that the angles are all the same, but I'm missing a side. So I can solve it. I can take those two triangles. I can put the side I do know, 7 of the big triangle, over this other side I do know, 3, equals, and then use the side I don't know, x, over the other side, its corresponding side I do know, 9. From here I can cross multiply. 7 times 9 is 63, and 3 times x will give me 3x. I'll divide both sides by 3, and x equals 21. The missing side I did not know was 21, and I did this by setting up a proportion and cross multiplying. It's very important to remember, however, that the proportion must be set up correctly. In the previous problem, I did 7 over 3 equals x over 9. But what if I were to do 7 over 3 equals 9 over x? Would the answer come out the same? So I can do 7 times x equals 7x, and then equals 3 times 9, which is 27. Without having to go any further, I know that 27 divided by 7 is not going to give me 21. So I am not able to put it in any order that I choose. I must follow the exact proportion. So let's practice. Two similar triangles, missing side x. So I can set up a basic proportion again to solve this. Let's do x over 21 equals 8 over 12. Look how I keep the order of the two triangles the same. Small over the big side, small over the big side. I cross multiply, which gives me 12. X equals 168. I divide both sides by 12, and I get that x equals 14. My next two problems will require a little bit more thinking to set up, but will ultimately use the same principles to solve. In this first figure, I have two triangles where one triangle is within the other one. In order to find that x, I can still set up the small side x over the big side that it is a part of, 24. So that x over 24 is going to equal 10 over 16. Again, small side triangle over the big side of the triangle. From here, I can cross multiply. 16x equals 240. And as I divide both sides by 16, I get an answer of x equals 15. So you see, it was all about setting up the proportion correctly and then doing the basic cross multiplying and arithmetic. Last example, I have two triangles facing each other. It's important to note that in this case, the 3 is proportional to the x, not the 8. So 3 over x equals 6 over 8. I cross multiply in this case. 3 times 8 equals 24. X times 6 equals 6x. Divide both sides by 6, and x ends up equaling 4. Again, I look carefully at which side is proportional to the other. Important connection with triangle similarity is how important it models to real-world scenarios of drafting and design.